Hi class, welcome to the last video for Unit 3. This is all about functions. This goes along with homework 22. The topic for this unit is functions. So we're going to go over some definitions, and those definitions are going to be probably a little more important in whatever class you take next. We're going to focus on just sort of one aspect of functions. So we use the term relation here to describe any sort of equation that describes a relationship between two variables. So sometimes these are just ordered pairs of points saying these points, this x is related to this y, or it can be an equation of some type. A function has this special rule: each x value has exactly one y value associated with it. So, for example, if I do something like x equals y squared, that's a relationship connecting the variable x and the variable y, but it's not a function because in this case I can have 1 equals 1 squared, but I can also have 1 equals negative 1 squared. So there is an x, 1, which is actually related to two different y values. So that's what makes it not a function. When we use the term domain, we usually mean the x coordinates. Sometimes people say it's the stuff that is all right to plug into the function, and the range is the y value. What are the things you get out of the function when you plug it in? What are some reasonable things to do? For example, if my function is describing the cost of producing items, then a domain would mean I couldn't put in negative. I can't produce a negative number of items. So my domain would include 0 and up, for example. And in fact, in that case, if it was producing pairs of shoes, my domain would be whole numbers, like 0. I can produce no pairs. I can produce 1 pair, but I really won't produce and sell half a pair of shoes. So here's an example of a relation. It's ordered pairs. This says 4 is related to 9, negative 4 is related to 9, 2 is related to 3, and 10 is related to negative 5. Is it a function? And the answer here is yes. There is no x that appears twice. So your concern would be if I added something like 4, 1 to the list, then it wouldn't be a function, because in that case 4 would have two different y's that it was related to. So because that's not there, it is a function. And then the domain is going to be all the x's that I see. So there's a 4, there's a negative 4, there's a 2, and there's a 10. So those are the domain, those are the x's. And the range is 9. I don't need to write 9 a second time. 3 and negative 5. Those are the possible outputs that can come from the function. When you're looking at it graphically, a graph is a great way of representing something, then the points on the graph are all ordered pairs. That's one of the things we've been learning in this unit. And so those ordered pairs are a relation. So the graph is also a description of a relation. And there's a cool visual thing. If I draw any vertical line, so any vertical line, and it crosses my graph more than once, then that means there's an x, namely the value right there on the x-axis, that is related to two different y's. So in that case, it is not a function. So if a vertical line passes through it more than once, then it's not a function. So this ellipse type oval thing you see is a relation, but not a function. Now, we've been focused on lines. Lines are an equation that we're kind of familiar to, and the only one of those lines that's bad in terms of being a function is a vertical line. So the vertical line, which remember has an equation like x equals 7, that's not going to be a function. It really fails the vertical line test, but all the other lines will be. Now, the notation that we use for a function, you'll hear somebody say f of x. That's sort of how this is pronounced, f of x. This is a function of x, function of x. You can use lots of different letters, but this notation is saying I'm going to do something with x's according to this rule. So I might use f of 2, and that means plug in 2 to whatever formula I gave you. And on a graph, it's going to be like 2f of 2. So just as an example, if f of x equals 3x plus 5, then f of 2, sorry for that noise, guys, f of 2 is 3 times 2 plus 5. So this means evaluate this formula, this function at 2. So this is 6 plus 5. This is 11. So f of 2 is 11. Notice we don't do anything with this notation. These are like instructions to you. Plug in 2 and see what you get. You get 11. So here we have a function and several evaluations we can do. So f of 0 is 2 times 0 plus 1 plus 4, sorry. And 2 times 0 plus 4 is 4. So this means if I were to graph it, I'm going to graph the point 0, 4. But for the most part in your homework, you're just interested in when I plug in 0, what value do I get? F of 1 is 2 times 1 plus 4. This is 2 plus 4, which is 6. And f of negative 2 means evaluate at negative 2. And I get negative 4 plus 4, which is 0. So there are 3 examples where we've evaluated a function. Some of the problems that you'll have in this unit will be word problems. They'll all be formula word problems because you'll be given a function in the problem. So in this one, the area of a man's backyard is given by the function below, where x is the width of his backyard. Sometimes the story problem will be really long, kind of explaining to you where the formula comes from. But for your part, once you have the formula, that's what you're working with. Eventually you'll get to courses where you have to develop the function yourself. So if the width of his yard is 10 feet, that's like asking you to do A of 10. What is the area of a 10-foot wide yard? So this formula says I'm going to do 10 times 48 minus 2 times 10. Do parentheses first. 48 minus 20. 10 times 28, and this was 280, and it's square feet, 280 square feet. The cost in dollars of producing t-shirts for the math club is given by this formula, where X is the number of t-shirts produced. Notice they're about to explain to you where that came from. If you're curious, this is because there is a $30 base charge, that's the 30, for any order, and a $7 cost per t-shirt. That's where the 7 comes from. If the math club wants to have 150 t-shirts produced, what will it cost them? So ultimately, this whole thing is asking you to do C of 150. What will the cost of 150 t-shirts be? So you're going to do 7 times 150 plus 30. And this is 1050 plus 30. So this is 1080. We were talking money here, so money, dollars is our final answer. If you have any more questions on functions, please let me know. Remember to practice not just the ones where you get an equation, but also the ones that are word problems when you're preparing for this homework. Thanks. Bye.